Look at our sun. 1 million Earths could fit inside it. It is so vast, so violent, that its light takes 8 minutes to reach us. And yet, in the catalogue of the cosmos, our sun is barely a spark. There are stars so large, they would not just swallow the Earth. They would swallow the Earth's entire orbit. Tonight, we climb the ladder of giants, all the way to the largest star humanity has ever found. To understand a giant, you first need a ruler. That ruler is the Sun, 860,000 miles across, a sphere of fire so wide that 1.5 million planets like ours could vanish inside it. Hold that picture, because from here, every single step gets harder to believe. Most stars hide the truth. The points of light you see at night are mostly small, close to the size of the sun or less, but scattered among them are monsters. The first rung on the ladder is Sirius, the brightest star in our sky, nearly twice the width of the sun, and burning far hotter, far whiter. Keep climbing, Pollux, Arcturus, aging orange giants that swell as their fuel runs low, 10, 20, 25 times wider than the sun. If Arcturus took the sun's place, it would stretch a quarter of the way to Mercury, and we are still only at the foothills. Aldebaran, the red eye of the bull, glows about 40 times the size of the sun. Drop it into the center of our solar system, and Mercury would skim just above its burning surface. These are no longer stars as we know them. They are dying suns, bloating outward into the dark. Now, the supergiants. Betelgeuse, the red shoulder of Orion, 700 times the width of the sun. If it sat where our sun sits, its surface would reach past the orbit of Mars, engulfing Mercury, Venus, and Earth, swallowing our entire world without a trace. And one day, in cosmic time, it will explode. Antares, the burning heart of the Scorpion, around 700 times the sun, and so cool and thin at its surface that it barely holds an edge. A star this size fades into space like smoke, with no clear line where the star ends and the void begins. The ladder is bending toward the impossible. VY Canis Majoris, 1,400 times the width of the sun. Light, the fastest thing that exists, would need more than 5 hours just to travel once around it. Around our own sun, that same lap takes 15 seconds. 5 hours against 15 seconds. Let that gap sink in. And then there is UY Scuti, around 1,700 times the sun. Place it where our sun burns, and its surface would swallow Mercury, Venus, Earth, and Mars, then reach outward past the asteroids toward the orbit of Jupiter. A passenger jet that never stopped would take almost 1,000 years just to circle it once. But the largest we have ever measured wears a colder name, Stephenson 218, around 2,000 times the width of the sun. Drop it where our sun sits, and its surface would race past Jupiter and reach towards Saturn. You could pour nearly 10 billion suns inside it. Light itself would need almost 9 hours to make a single lap around its edge. So why don't stars simply grow forever? Because at these sizes, a star is barely holding itself together. Its own light pushes outward with such fury that it begins to tear its own surface away, bleeding it into space. There is a ceiling written into the laws of physics, a point where a star becomes too bright to survive its own brilliance. And giants die hard. A star like this ends in a supernova, a single flash that can briefly outshine an entire galaxy of 100 billion stars. What it leaves behind may be a neutron star, a city-sized ember, or if it is heavy enough, it collapses into a black hole. The largest stars in the universe are the factories that forge the darkest objects in it. We measure these giants in suns because our minds have no other handle for them. And here is the part that should keep you awake. We keep finding bigger. Every new survey of the sky pushes the record further out, into stars we have not yet named. Somewhere out there, in the dark between stars, a true giant is still waiting to be found.